Hello all, and welcome to today's PSU Transportation Seminar. My name is Jason, and I will be introducing and moderating today's seminar. There we go. Our Friday transportation seminars have been a tradition since the year 2000. These seminars are usually held live on Portland State University's urban campus, located on the ancestral homelands of the Multnomah, Cathlamet, Clackamas, Tumwater, and Walala bands of the Chinook, the Tualatin, Kalapuya, and many other indigenous nations of the Columbia River. It is important to acknowledge that we are here because of the sacrifices forced on the indigenous ancestors of this place, remember these communities, and to honor their legacy, lives, and descendants. Today, we are pleased to have our own Li-Ming Wang presenting Assessing Reproducibility in Transportation Research with Large Language Models. Dr. Wang is a faculty member of the Tulane School of Urban Studies and Planning at Portland State University. While his primary research is integrated land use and transportation modeling, he has recently caught the AI LLM bug. We all have, and is now exploring its application and impact on transportation research and practice. Here's some information about our final seminar for the fall term. So remember, we have a holiday break, and then we have our final seminar with Joe Broach from Metro, and then it's the end of the quarter, just like that. For those of you who are PSU students, STEP is a community of students passionate about shaping safer, smarter, and more connected transportation systems, and brings together students from across several disciplines for guest speakers, field trips, and other events. STEP is open to all current PSU students, and they are excited to meet more students interested in transportation. As an overview of today's seminar, you can expect our speaker to present for about 45-ish minutes, which will then be followed by a Q&A session. For those of you online, we will be receiving questions through the Q&A feature on your Zoom control panel. If we run out of time for all of your questions, we will give our speaker the opportunity to email written responses for any questions left unanswered. We've also enabled closed captioning, but you must click on the CC feature to view them. We will be recording today's webinar. It will be available on our website later today, along with the presentation slides. If you are tracking professional development hours, this webinar is eligible for 1 hour of continuing education credit. For those of you in the room, we'll pass around the sign-in sheet so that you can get credit for attending today. And without further ado, I'm going to hand it over to Li-Ming.
Okay, thank you, Jason. So for today's seminar, we'll talk two topics, a combination of two things that are near and dear to me. So first, I want to acknowledge that this is a collaborative work with a rather large group of collaborators, mostly from the US, Europe, and Canada. They're loosely organized as a group called Rewrite, Reproducible Research in Transportation Engineering. I don't have a role in coming up with the name. I hope it's more inclusive, but it is what it is. In terms of the outline, I will, for my talk, I will start with some definitions and motivations. What is reproducibility? Why you should all care about reproducibility. And then we'll talk about what the data we use for this research, the methodology that we used before we get to the results and future work and a bit of takeaway from our research. Okay, what is reproducibility? According to kind of the field of meta science, there are a few different levels of reproducibility. A term I believe you'll at least heard of, or in passing, or in many different kind of situations. So the first level of reproducibility is what we call the availability. Is make the artifacts used in a research process available, right? So in a repository or a website that hosts those, GitHub or other data repository has been doing that, or researchers have been utilizing those. So this is the first level, and not making those data or code used in research available, of course, make it impossible to reproduce or talk about other higher levels. The second level is reproducibility. Is basically other researchers will be able to obtain consistent results using the same data, same input data, and then follow their computational step, ideally using the same code that researchers shared, and then the same conditional analysis and so on. Okay, so that's second level. Finally, is replicability. Is that all the researchers will be able to obtain consistent results across study and answer the same scientific questions. Right, each of them will basically conduct their own experiment, collecting their own data, and so on and so forth. So those will be the highest level of reproducibility. Will be after you confirm replicability, you basically have the most robust possible scientific results, scientific finding. So when we heard that kind of half of the papers fail to reproduce in a certain field. I believe even medical field is about half, 50% or so. Those are typically replicable. Only half of those will be able to, other researchers can replicate them. Okay, but of course, it's the golden standard, but still will be able to have those artifacts available, be able to reproduce those results are still a valuable contribution, a valuable step to ensure reproducibility. But why should you all care about reproducibility? Okay, so we publish papers, we have results, you should just trust us, did our best. Those are researchers, academia, and whatnot will certainly put a lot of effort to those. But I would argue reproducibility is critical, it's crucial to both anyone care about research. For that's pretty much anyone you will direct or indirect impact affected by scientific research. So for researchers, I would say you yourself are the primary collaborators 6 months from now. So when you come back to looking at your own work, you may actually have a hard time to figure out which version of the code, which version of the data actually used to do the research. Right, so ensure or practice reproducible research allow you to actually collaborate, right? Have an easier collaborator to work with 6 months, a year, or a few years from today, from you conclude your research projects, right? And then also you allow others to build on your research. It's kind of similarly. For other researchers, when they share their code, share their data, make it a lot easier for you to utilize, to build on their work, right? To basically accelerate scientific research. But here we do have suffer from a so-called free rider problem, right? So if a researcher share his or her code and data, other researchers will be able to basically utilize or build, and build on their work. But on the other hand, if other researchers are not reciprocating, are not sharing their work, those who share their code and data will be at a disadvantage, because academia scientific research is a highly competitive field. Right? So for those that if we are not kind of having a norm to have everyone sharing their work, sharing their data code, and those are doing so is basically at a disadvantage. Okay. And then finally, there is a problem of scientific integrity. I will jump back a bit. So if you want a story of a rather nefarious story of basically fraud in scientific research, I highly recommend this podcast from Freak Economics that a few researchers actually in a rather high profile University of Harvard and elsewhere, they basically kind of create fake data and create a fraud basically and publish in high profile journal, and has basically a lot of policies created based on their research, but it turned out to be a total fraud. Having, again, requiring or facilitating reproducibility is basically create a safeguard for those type of fraud. So in this particular case, other so-called whistleblower, had they not be able to access to the data, this fraud may never be caught. So you only have their results showing in the journal, and you will not be able to examine their data, and then there is no evidence to support a fraud there. Okay, I will argue even for practitioners, reproducibility matters. It saves both time and money to translate research into applications, into product, right? And then also facilitate trust between the community. And however, it's not easy to do reproducible research, to follow a reproducible research practice. It's also very difficult to assess reproducibility in published articles, published paper, because it's a very tedious and assessment. It's very tedious and time and labor intensive practice. I will show you a few examples why that is the case. So because of this reason, reproducible research or assessment has been relatively small scale. They usually focus on more than a few hundred papers, and then typically focus on a few aspects of the paper or publication. They're typically pretty ad hoc. They're only doing it once for a particular time points for a specific community. And then even potentially biased, only focus on a small set, because the selection of the set will be a problem. Okay. So just to give you some example of why it's a challenge to extract information from a published journal, published paper about reproducible research. So ask a question, give you a paper and ask you, is the data available? Is the author make their data available for this particular paper? It's a harder problem than you thought. For some paper, of course, it's clear. It's a clear cut. They have the data, and then you can find it on a link and so on. But for many, it's trickier than you thought. For one, some people use many of them, right? So they could potentially just make a subset or one of them available. Some papers use a public data source, so-called NGSIM is a data set, public data set that used by a lot of transportation engineering research. But if they do not share their code for processing the data, you won't be able to reproduce those results either, right? So, and then there are cases where the author points that, or they even provide a data availability statement, indicate that the data is somewhere, but you cannot find it. That URL is invalid or it expired, and so on and so forth. Okay. So another example of it's challenging. You might imagine, actually, it's not too hard to use a computer to use so-called pattern matching to find the link to see whether there is link for data or code in the paper. So this is another example from an actual paper, again, for traffic prediction. So here in that paper, it has a number of links in there, right? So you can extract all of them, but does the paper actually provide the code that implement the research conducted in the paper, right? So are all of them actually code used in the paper, or are some of them just in the citation benchmark against by the author and so on? So if you read the paper, the final link is the actual link that provide the code implemented the research or proposed method. So this is where we think actually LLM is, we start the project, I think in early 2024. So when LLM for one eventually has gained a lot of attention. So we think whether LLM can offer a potential solution for scalable, deep, repeatable, and unbiased reproducible assessment. And there are a number of research in other fields, actually, primarily in AI research, that actually try to basically come up with so-called agents, LLM agents that can help you do reviews, can even potentially replicate other research. But we found now in the transportation field so far. In terms of data set, we use the articles, papers published in the transportation research series. Basically from part A to part F, they have 6 journals in that series, and in addition has the open access journal called Transportation Research Interdisciplinary Perspective. We use the data from all the articles from 2019 to 2024. For those of you not familiar with the transportation research publication, this is one of the flagship research or a few of those top flagship research journals, because we have 7 of them here. As Elsevier is the publisher, and the publish depends on the particular journal to publish somewhere between 100 to 400 articles per year. Top there are those number of articles by journal and year. And Elsevier has a research data guideline. It's what they call the research data guideline. They provide option A to E in terms of what the data, will be provided. For option A, they encourage researchers to authors to deposit their research data and cite the data set in their paper. Okay, option B adds additional requirement in that if the data cannot be shared, provide a statement why that is the case. All the way to option E, where the data deposit repository is required. There's required to provide those. I believe so far, a few of the journal, in particular Transportation Research Part C, adopt B as well, adopt option B in this case. It encourage authors to deposit their data, cite them. If it's not possible, provide a statement why the data cannot be shared. Okay, in terms of methodology. So of course, believe all of you, at least you probably used LLM at this point. It will be, of course, made a huge progress over the past couple of years. But when we start, actually, the problem of so-called hallucination of LLM is a huge problem, especially when you have a large amount of text to pass to LLM. So before we actually use LLM to do any serious scientific investigation, want to make sure that LLM is producing valid and robust results. Okay, so we first go through a validation, basically validation process. We collect data, we recruit student and faculty to help us create a human review data set. So we select 100 paper randomly from those 10,000 papers in the transportation research series. And we have 27 researchers to help kind of fill in forms and provide information about each paper. Okay? And then we kind of go through the 100 paper through a human review process as well as LLM. We compare those results. If there are kind of major discrepancies, we will diagnose and figure out what might be the problem in our prompt, and then use that to refine our prompt. Okay, since we have the LLM as a pretty capable tool, we at the beginning we went a little bit overboard in terms of what are the features that we want to extract from each paper. So here is our so-called version 1 features. So we even ask LLM to extract basically every single data set, the name, whether it's publicly available, and so on and so forth. Okay. Of course, it worked, at least for LLM prompts. It can return all those results. The challenge actually is for human reviewers. It turned out to be a lot more work for human reviewers than what originally thought. Okay. There is a lot of missing or mismatch between even 2 human reviewers, not mention what returned from LLM versus what human reviewers be able to capture in their survey form. Okay, so we end up collecting a much smaller set of features or information about each paper. We focus on whether it is a quantitative study, whether there is a code available or the author provide a code for the paper, and then is the code link still valid? We can still download those code there. Similarly for data, is the data used by the paper, and is a data repository available, and is the data link valid? Okay. So after going through those, we compare the level of agreement between human reviewers and LLM. Okay, so those are the results. So it typically has kind of, even among human reviewers, has between 40 to 84 to 90% of agreement. So those are the percentage of papers where 2 human reviewers agree with each other. Okay, so make sure every paper, every of the 100 paper actually has one review. Okay, and then we compare the LLM extract information on each of those 4 questions against human reviewer 1, human reviewer 2, and as you can see here, they have pretty much a similar or sometimes even higher level agreement between LLM and human reviewer. So those give us some confidence. Actually, it worked pretty well. Okay. And this is the final prompt we end up using in our research for both the data features and code-related feature. Okay, LLM will be able to return the results in a JSON format that we post-process to for our final. Okay, and this is the final so-called workflow for all the data we extract in those 10,000 plus full-length paper. We basically scrape or download all the articles from Elsevier API, collect all those XML in XML format, or the default format returned from their API. And we extract the text and metadata using some code we wrote ourselves, and then we pass those text and along with prompt to LLM. Gemini Flash 2.5 is what we used in the end. Of course, when we started, actually, we only have 2.0, I believe. In the end, the final iteration we used 2.5, and then we extract all those availability features for each of the articles, 10,000 articles. Okay, so what is the results? It's probably not total surprise. We have about 4% of the articles that used data, share their data, or share all of the data in their paper. And then about 5% of articles that used quantitative, labeled as quantitative study, shared their code. Okay, so it's only not a high percentage. Before we actually collect the data, we think it's probably not too high, but it's still a bit surprised by that lower number. Okay, and then this is how it's split among those papers, 10,000 or so papers. To label all of those different split there. Of course, huge major percentage of the paper do not have their data available. Some of them, some data available, but not all of them. And some a percentage of them use code, and the majority of them do not have the code available. So, okay, and looking at specifically by journal. On the top is what we showed before, is the number of articles published by journal and year. On the lower left is the percentage of articles sharing code by journal and year. So those are, right, so here TRC stands out in that it has see a witness or see a uptick in the percentage of both in the percentage of articles sharing code in 2023 and 2024. And then other, of course, you maybe see a bit uptick in other as well, but because of the percentage of the number is too low, we do not have confidence. Actually, it's not due to a pure chance. We see a similar pattern in percentage article sharing data. Again, TRC, Transportation Research RC, has seen a bit of uptake in the last 2 years of the data. And we also want to see whether there is a difference in by topic, right? There is a number of transportation topic, that topic area. Of course, there is no agreed upon kind of topology of classifying transportation research into topic. Here we build on research by other researchers for in terms of thing and topic in transportation research, classified in a dozen or so topic area among the research, and then we be able to classify those each of the 10,000 articles into each of the topic area. Okay, in general, again, similar pattern there. It's relatively low, but on topic area, the modeling and prediction actually stands out a bit in that it has a higher percentage compared to other topic area. Okay, in terms of their sharing their code, they could as high as like 20% of the article, 15 to 20% of the articles in that specific topic area sharing their code or data. And there is a bit of variation by so-called continents. Here we're looking at those by continent. Of course, there's a bit of noise there because some of the continents like Africa has a very small number of articles published by authors from those continents, and similarly for South America. So in end, what stands out, kind of both Europe and North America authors have a higher percentage of articles sharing code and data. Okay, one thing you may care about, curious about is, do authors, papers sharing code or data have get cited a bit more, right? So we talked about free rider problem. Does sharing those provide at least a bit of incentives, so people cite or use their work a bit more often? That is to provide partial incentives for people to share in their code and or data. Okay. Unfortunately, we didn't see that pattern at all. Okay. Kind of a hypothesis. We do not have a clear direction in the beginning before we analyze the data. So here again, it's by journal. The x-axis is the journal, and then the left is whether a paper share code or not. So the brownish color is no, and then the purple is yes, true. And then as you can see here, there's basically no clear pattern in terms of the number of citation by journal and by whether they share their code. And similarly for only right there, whether the paper share their data or not. There's no clear advantage for paper that sharing their code or data in terms of citation. Okay. Of course, one confounding factor is the year when the article published, right? So you imagine that the paper published earlier likely to have a bit more citation than those published later. We then divide those by year. Even divide those by year, it's no clear pattern there either. Okay, so each of this plot represent 1 year from 2019 to 2024. Again, no clear pattern one way or the other. Okay. And what about review time? Does it at least provide a bit of advantage for the author to go through the review a bit sooner, right? So theoretically, what you may think is that by providing the code or data that the reviewer, you may all at least aware that most scientific publication, a article will require a few from somewhere between maybe 2 to 5 or higher reviewers, most typically anonymous reviewer, so-called peer review process, before it can get accepted and then published in the journal. All the journals I reviewed in the transportation research series are peer-reviewed journal. So all of them go through that process. So by providing code or data, does reviewer actually are able to get access to those and then speed up their review process? Again, unfortunately, there is no clear advantage of sharing the code or data either. Okay, it didn't speed up the review process at all, from the submission to the final acceptance. Y-axis there is review time in days, and then the legend is right here. So the purplish is now not sharing their code, and then the green color is those sharing their code. And then there is no clear pattern in clear difference between those two groups either. Okay, so this actually demonstrate a advantage of using LLM is that we are able to extract information for all papers, right? So if you use a smaller, imagine if you're doing this a subset of papers, 100 or a few hundred papers, it's even harder to be certain whether there is a clear difference between the group. Even with the complete data set, entire data set, there is no clear pattern between those two groups. That gives us a bit more confidence that actually it didn't give us a much advantage or doesn't provide much incentives authors to share their code or data. Okay, this is still an ongoing research. We're still kind of looking into the reasons the authors provide for not sharing their code and data. So of course, the options, the data, research data guideline adopted by Elsevier, it's only recent. I believe it's probably officially adopted on their website, on their guidance for authors in 2024. So before that, there's no clear guidance of what the author should do in sharing their code and data. So in many cases, no reason is provided for not sharing data or code. And then a few other, including data will be made available, is probably next to non-provide is on request. And then also authors do not have permission to share their data, and the data is confidential to share. Okay, in terms of ongoing / future research, we ultimately, the vision is to help to develop a tool that automate the whole process, the whole workflow. Will be able to basically you provide a paper, and then the LLM will be able to again assess whether the data code is available, and then can be able to proceed to the second level to reproduce the actual paper. Okay, use the data and code available. There may be in the future a more futuristic vision is that the LLMs or so-called agents, AI agents, will be able to basically do their own research and then pursue or verify the replicability of specific research. But so far, we are aiming for at least the second level of reproducibility verification. Given the data, given the code, can we reproduce, can we produce the same finding, the same results, okay? So that is what's on top on our to-do for this project. And then, of course, there are, as I mentioned a bit, there are certainly potential for LLM to automate those in other fields that's already at least have some publication came out by some of the major so-called AI labs, AI companies, including Meta. They have a paper that actually published, just came out not too long ago, on automating the reproducing so-called nano GPT. It's kind of the replication, a smaller scale GPT, and then automate using LLM to reproduce those results. And then there also work in trying to convert a published paper into a so-called agent so that you don't have to basically read those paper line by line, but be able to interact with a paper, so-called paper to agent. But the focus there is not necessarily trying to reproduce validate the research. The agent is just reinterpreting, rephrasing finding in the paper. Okay. And the last paper we find actually kind of in the same or similar spirit is paper bench, focusing on the AI field and evaluating whether AI agent will be able to reproduce journal articles submitted. I forgot which conference is one of their top AI conference. So those by OpenAI. In a longer or more expensive scope, there are other work trying to develop a so-called AI co-agents or a co-science or AI scientist. So there are some work by Google and another startup. At least I believe there is quite a bit of hype there as well, claiming that their AI agent will be able to produce novel scientific discoveries. Okay, so listed here, of course, the capability of LLMs indeed improve rather quickly over time. So this could be a vision that could become a reality in the future. So in terms of takeaways, what are the takeaways from our research so far? From the results, it seems, at least so far, it's a short, only 2 years. The data recommendation or guidelines provided by the journal and publisher indeed seem to work. TRC being Transportation Research Part C, in one example there, that by having those guidelines in place, we did indeed see an uptick of articles, papers sharing their data and code. And another takeaway, a more optimistic kind of take, is that it is possible. It is possible to change the practice. These are a summary of similar research in other fields, of course, primarily in computer science and engineering there, that many of the field actually have a much higher percentage of the paper sharing data and code. Talking to people in those fields, those are not the norm. No, those are not the norm, not even too long ago. Okay, they did actually change the overall kind of norm of sharing data and code. Okay, so you can see here, I highlight on the row there for security, 40% of them sharing their code, and 64% of them sharing their data. So I think indeed I want to be optimistic that we can kind of do the same or be able to make a shift in the transportation research as well. And then this is where rewrite comes in a bit, that it provides work together with a large group of collaborators. We have been putting together some training in terms of what are the basic practice of reproducibility in transportation research, as well as some help disseminate some of the research, kind of highlighting the data set, open data set, or research that publish, sharing their code. Okay, and then this is also kind of LLM as a tool. We do think that LLM could potentially be helpful in helping generating the code, right? So there's a lot of researchers that have reservation of sharing their code, as they think it's pretty poor quality, not well written, not well documented. This is where a so-called code agent can help kind of mitigate that a bit there. And even to the extent that to adopt some of the best practice of so-called literal programming, that you can basically regenerate your final paper, final report from the raw data inputs and the final product in a reproducible pipeline. Okay, with that, I will close and happy to answer any questions you may have.
Awesome. Thanks, Li-Ming. For those viewing the webinar, please feel free to submit your questions using the Q&A feature in the control panel on the bottom of your Zoom window. We'll take some questions in the room. I'll let Li-Ming call on folks, and then we'll stop with a little bit of time left to answer some questions from online.
Really interesting. As a editor of a journal, some of these topics I think about quite a bit. Fraud, which is one of the motivations. But I appreciated broader reasons you gave researchers and practitioners of why this is important. I think I have lots. One quick question. Remind me, and maybe for other folks, tell them for the first time, transportation research part C, what is the focus area of this?
Emerging technologies.
Emerging technology. Okay. So I was trying to link like what about that might make it more likely to have the data, etc. And I guess the other thing is more of an idea. I really appreciated how you tried to think like what are the motivations for sharing data and code, and by looking at citations or review time, is it showing up there? Unfortunately, no. So another aspect is well, related to citations is citing the code itself or the data itself. So that's another. And I don't know if there's standard practice of, let's say I use someone else's data and I publish on it. Am I using the citation of the paper that it was first shared through? Or I think I'm sharing the citation for the actual data repository. So is there a way eventually your LLM could be looking for citations of the actual data?
Great. That is a great question. On a few fronts. So in terms of the practice of citing data, it is certainly possible that some of the now kind of specialized data repo, including Dataverse being one, the NATO, I believe it's another, and manually it's doing some of that as well. Some of them do provide a DOI for the data set you upload to their repo, so other researchers can cite those. Along that kind of similar vein, there are now journals specifically focused on public data set. One of, I believe, Nature, forgot the exact name of the journal, I can only look it up. It's kind of Nature Open Data or something like that. That again, the author will still provide a writing up, but the primary focus is have a data set attached to that publication, and other could cite those. I believe that's not a single example there, but that's at least one I remember. In terms of whether LLM can detect, I believe that's again one of the advantage of LLMs. It can understand the context of each citation. So that's an advantage of compared to kind of pattern matching example. There, you do have to understand the context of that citation and so on. So far we haven't gone there yet, but it's only a good point is whether the practice of sharing an open data set will be counted as a kind of a contribution, or whether the trend of publishing a data set is kind of cited as much or credited as much as doing other work, but kind of producing data set on the side. So yeah, good point. Yes.
So I have like a two-part question. The first one kind of goes off of what Jennifer was mentioning in terms of the scope. So like seeing part B and part C have the highest proportion makes sense based on the scope, right? Sharing their code for new algorithms to solve certain problems. And so I wonder if there's any thought on going beyond just the transportation research part series and grouping a bunch of journals by the scope and seeing if that holds up, seeing if journals with this scope have a really high percentage relative to the others or vice versa.
Yeah, that's a good question. This is more or less as a starting point. In our vision, our goal is to have a tool, have the code, of course. We will be practicing open science, sharing code and data, following or so-called dog fooding, I believe is what they called, eating your own dog food. And we will be sharing the code. And ideally, this, of course, it's kind of ongoing basis. At least on my mind, we'll be developing a tool that basically automate this and then can be utilized for basically any journal, any fields, for any fields. It doesn't have to be limited to this transportation research part A series and yeah, so that's the vision there. It's not there yet. We still kind of the code again are putting there. The code is all scattered in a number of different repos. We only need to clean up and streamline the code, make it usable by all the researchers. And in terms of I think it's a good point that it's only a correlation between the scope of the journal and then the tendency of sharing data and code, right? So both part B is methodology, transportation research part B, the focus is methodology. For part C is emerging technology. Those are the researchers, those are the field that utilize the code and data a lot. They rely more on those. And then they're basically more likely to share that. I believe they also showing up in the topic as well, right? Similarly for modeling and prediction, optimization, I believe showing up here as well. That those fields, those topic areas are more likely to share their data.
Those topics are in part B like a lot, right? Where the contribution is like the code and the data. Right. So that's not surprising to see.
Right. Yeah, so a kind of a counterpoint, even supposedly the methodology is we ideally pretty much nowadays all, if not all, it's only a very high percentage of researchers using computer to do their research. Right? So even in transportation part B or C, still a minority of the authors share their data or code, right? So it's the highest is about 15%, 2024 in transportation part C. Yes, and
as part, I guess, part of when you're sharing your code, what's the obligation to the author to maintain it?
That's a great one. That's a great one. No obligation at all. So we want to look into that. We haven't have all the data yet. We have experienced a lot of cases where they indeed share the data or code, but the URL has expired either totally offline or has been redirected to something that's irrelevant. The original URL has been deprecated. It automatically redirect to somewhere that's not relevant to a specific data set. That happens quite often, especially for older articles published in earlier years. 2019, more likely to have those C deprecated URLs. That is a great point there. Again, this is where kind of go one level up to actually find their URLs, find their data set to see whether you can download those and then further reproduce the finding will be beneficial, or kind of make sure that all those are still there, and then you can still download them, and you can still run the code. Go one step further, I'm not aware of any incentives or even any suggestions in terms of what incentive you want to put in place to make sure the original author keep working, keep updating the code, right? So for that matter, the data. There is nothing in place. I cannot even imagine what a practice look like. Yeah, ideally you want that to happen, but there's no practice at place. I'm not aware of. Yes.
I guess as a follow-up to that, it's one thing to like cite the repository in a publication, but I mean, as like, for example, using GitHub.
Right.
I mean, are other authors or researchers aware that, maybe not just, citing the URL, but, either starring the repository, if they used it, or just knowing that it's been worked a bunch of times.
Right.
Like developers know how to do that.
Right.
Out of curiosity, but everything else.
Yeah. Another good point. Yeah, that is there is a gap in terms of how credits are attributed in the academic fields, academia versus the software engineering field. That's totally a valid point. I don't see that permeate anytime soon, except maybe some of the computer science field, right? Because they're the blend of the two, right? So software developers get credit when their repos get starred by or forked by a lot of people, and if they produce a paper or if they have a paper accompany those, typically their paper also gets cited by people as well. But outside computer science, I'm not aware of any kind of practice recommending that doing both or giving credits where it makes most sense.
So then, I mean, as part of rewrite, like, is that like put forth guidelines for people?
Right, that's a good point. I will certainly bring your points back to folks in the group to see whether that is something we could contribute. We can advocate a bit.
It would just be easy to add README to the repository. They open it, it's like,
Right.
hey, you're gonna take this, please do X.
Please also, start over or okay.
Quick one. So as a practitioner, the way I read papers, if I read them at all, is I read the abstract and then I skip the discussion and confidently assume that the researchers and peer reviewers worked all the methodology stuff out intently based on my own grad school experience. Is it safe to confidently tell, stakeholder groups that their anecdata is wrong because I have this research paper that says so? The way I've been doing based on kind of what you're finding here, have the standards at Elsevier, has that changed in the 15 years since I was in graduate school? And I had thought that a lot of this traceability was handled there. And does it make sense to kind of have, in addition to the peer review, which used to be the stamp of this is right, does there need to be maybe another standard now, like a Twitter check mark of it passed the peer review process and we were able to find all the data.
That's what I would think so. We should have a kind of a stamp, a badge for whether the research has been reproduced, replicated by others, right? So as kind of a reviewer, author myself, what I can tell you is that we didn't go through the process of reproducing the results. As a reviewer, we only have access to the paper in most cases. Even when a data and code is shared, we typically do not have time and time or energy to reproduce the research to make sure that the data is valid, and then we can reproduce the results, not mentioned to be able to replicate it. Right? This is where the whole reproducibility crisis, basically in many fields now, that demonstrates it's that many of the scientific research supposedly going through many cases very rigorous peer review may not stand because again, some case they're fraud, malicious authors trying to get published in a high profile journal and whatnot, as showed up in that free economics demonstrated by the free economics podcast. But in many other cases, it just airs by the author not caught, or for that matter, I believe a huge percentage of publications could potentially either accidental or intentional so-called p-value hacking. P-hacking is just kind of play with different models to make sure to, in the end, only report the results that are so-called statistically significant. And then that make it easier to publish in a journal.
Interesting.
Yeah, so
there's no questions online, so I'll go ahead and ask like the second part of the other question. So this is more like a high level view of it. So it's really important for reproducibility in my opinion, and it should be for most. And you mentioned that like it's something that can be done, but the competitive nature and other factors, people don't want to share their code. It may give, funding opportunity, whatever the reason may be, right? Like it puts them at a disadvantage potentially. And so they're like safeguarding like what they've created, with this really tight grip. And so I wonder, like beyond the journals, like requiring it for publication, which would probably change behavior, are there any other things that through your work that you could recommend or could be considered to improve the number of folks that willingly provide it without being forced to provide it?
Good question. It's kind of, again, pointing to what other fields, particularly computer science, has done, kind of changed the norm, right? So you can be kind of working together, that the community kind of make decide together that they want to advocate for a practice of openness and sharing. That might be something that I think, at least from, again, those are outside my own field there, and I do not know the exact history of how that transition happened. For those fields, from what I heard, is that some of, including so-called open view, some of the top computer science conference, they or pretty much all require you to have the code, share the code and data, and then this is also one of the reasons, I believe, from what I read, so-called AI fields has been able to move so quickly is because they share their code and data such that other can follow. Of course, there are exceptions. OpenAI is the one that's more like a closed AI compared to others. So another you mentioned, of course, kind of, I think another element, not necessarily self-organizing, being into change that behavior. Founder, besides publisher, founder could require the kind of researcher, investigator to share their data and code.
Yeah.
Right? In addition to maybe open access to the journal articles and so on. I believe some are start doing that, but it's still not in the norm in transportation. We can probably continue afterwards.
A little related to that, I was thinking along the same lines, like, how do we change that? Hard. But the University Transportation Center program, which is federal funding, has for several years now required anyone using that funding to have a data management plan and make their data available. And so it would be interesting to see of the recent published here, how many of them cited that program as their funding source.
And then share their data.
How many of them actually shared their data? Because those common excuses you had at the end and like, it's confidential, blah, blah, blah. Like, a lot of that is BS. Like, it's just that they don't want.
Right.
Yeah. Okay, fascinating.
Awesome. So thank you all again for attending today's Friday Transportation Seminar. For those of you joining remotely, after the seminar ends, you'll have the opportunity to complete a brief survey about today's event. It only takes a few minutes and we would really appreciate your feedback. So thank you, Li Ming, and thank you all again for joining us today.